Hey, Sci-Sippers! Are you ready to explore the mind-bending world of fractals? These infinitely complex shapes are everywhere in nature, from the branching patterns of ferns to the jagged coastlines of mountains. How can something be infinitely complex yet infinitely simple? Welcome to the perplexing world of fractals, where this paradox comes to life. Fractals are mathematical constructs that are infinitely intricate, full of twists and turns that seem to go on forever. Yet they are built from the simplest of equations. Now let's delve a little deeper. One of the defining properties of fractals is self-similarity. This means that a fractal is a shape that, no matter how much you zoom in or out, always looks the same. It's a never-ending pattern, a loop within a loop, spiraling into infinity. And it's this self-similarity that gives rise to the infinite complexity of fractals. So, here we have it, a paradox of sorts. Fractals, born from simplicity yet infinitely complex, are a testament to the mysterious and beautiful world of mathematics. They are a paradoxical blend of simplicity and complexity, infinite mathematical mysteries waiting to be explored. Consider a line. It's one-dimensional, correct? Now what if I tell you in the realm of fractals, things aren't as straightforward as they seem? In the fascinating world of fractals, we deal with something called the fractal dimension. This isn't your everyday dimension. It's a measure that transcends the conventional dimensions we're familiar with. So what exactly is this fractal dimension? Picture it as a mathematical tool that gives us a more precise depiction of a fractal's roughness or complexity. It's a measure of how detail in a pattern changes with the scale at which it is measured. Think about a crinkled piece of paper. Viewed from afar, it seems two-dimensional. But as you zoom in, you see more detail, more folds, more complexity. Its dimensionality seems to increase. This is the essence of the fractal dimension. It captures this scaling complexity. In the fractal dimension, lines can be more than lines and surfaces more than surfaces. It's a whole different ballgame. Think fractals are confined to the realm of abstract mathematics? You might want to reconsider. Fractals, these fascinating figures of infinite intricacy, are not mere mathematical marvels. They're deeply interwoven in the very fabric of nature, governing patterns and designs we often take for granted. Take, for instance, the Romanesco broccoli. Each of its spirals mirrors the larger structure in an infinite cascade of self-similarity. Or consider the branching of trees. Each limb, each twig, is a smaller replica of the whole, the same pattern, on a different scale. Even the formation of river networks, with tributaries feeding into larger waterways, echoes this fractal form. It's a grand design, repeated in myriad ways, from the smallest scale to the grandest. These examples are but the tip of the iceberg. From the arrangement of leaves on a stem to the spiraling arms of galaxies, fractals are more than abstract mathematical constructs. They're the building blocks of reality. Fractals, the fingerprints of nature, are everywhere if you know where to look. What happens when fractals meet chaos? A beautiful symphony of unpredictable patterns. When we delve into the realms of chaos theory, fractals emerge as a visual representation of these complex systems. They allow us to visualize and make sense of the seemingly erratic behavior of chaotic systems. Picture it as a captivating dance between order and disorder, where intricate patterns emerge from a whirlwind of randomness. In the world of chaos theory, the initial conditions of a system can greatly influence its future behavior, a concept known as sensitivity to initial conditions. Now, how do fractals fit into this? Well, fractals serve as the graphical representation of this sensitive dependence. They provide a means to visualize how minute changes can lead to significant variations, illuminating the beauty of unpredictability within chaos. Fractals and chaos, a match made in mathematical heaven, provide a lens to view the unpredictable in a new light. Intrigued by the infinite world of fractals, the journey has just begun. As we've delved into today, fractals are not merely mathematical curiosities, but a fundamental aspect of our universe. We've explored the enigma of infinity, the fractal dimension, the prevalence of fractals in nature, and their intriguing relationship with chaos theory. Each fractal, be it in a snowflake's intricate design or the branching pattern of a tree, is a testament to the beauty of complexity arising from simple rules. The fractal dimension, a concept so counterintuitive yet so profound, bridges the gap between dimensions, challenging our perception of space. Fractals and chaos theory, two seemingly disparate fields, intersect in a fascinating dance of order and disorder. As we've discovered, chaos isn't merely randomness, but a complex system governed by deterministic laws, often resulting in fractal patterns. Venture into the infinite world of fractals, where complexity meets simplicity. Remember to like this video and subscribe to Sci Sips for more deep dives into the enigmatic realms of science.